Alright, ladies and gentlemen, in this video we are going to look at using coordinate proofs to either prove or disprove that a particular point actually lies or does not lie, maybe, on a particular circle. So it's focusing on this bottom, number 6 success criteria of using coordinate geometry and coordinate proofs to prove or disprove a statement regarding circles. So let's take a look here at an example. It says prove or disprove that the point square root 2 lies on the circle centered at the origin and containing the point 2, 0. So let's think about this. What has to actually happen for a circle with the center at the origin and it containing the point 2, 2? What has to happen for root 2 to actually lie on that particular circle? Well, what does it mean for a point to be on a circle? What it means is that from the center of the circle to that point has to have the same radius, because if you think about it, and this isn't really part of the proof, but let's just kind of think common sense. If here's my circle that I'm dealing with, if I have a point right here that's going to lie on the circle, if there's a point here, it doesn't have the same radius, or if I have a point here, it doesn't have the same radius. And so what we're really looking is that square root 2 has the same radius as it does from 0, 0 to 2, 0, 2 points that are actually a part of the circle. So we can kind of say something of the nature, okay? A circle with center at origin and containing point 2, 0 would have a radius as follows. So we all understand that the formula for the standard equation of a circle, remember correctly, is x minus h quantity squared plus y minus k quantity squared equals r squared. Well, with 0, 0 and 2, 0 being our center and our containing point respectively, that means that 2 minus 0 squared is my x-coordinate of my point 2, 0 and my x-coordinate of my origin or my center, plus, in this case, 0 minus 0 squared. And that will equal r squared. I don't want r squared. I want r. So if I square root both sides, I see that r is actually equal to the square root of 2 minus 0, or 2 minus 0 squared, which is 2. So it's really just the square root of 4, which of course is 2. So at this point, what I've proved is I have proved that this particular circle has a radius of 2. And so what our goal is to now show that square root of 2 or square root of 2 does or does not have the same exact radius from the origin. So I'm going to kind of clear the screen here just so I can have some more writing room. So if you need to pause the video and take a look. And so we'll say, now that we know that the radius equals 2, I would say something of the nature of it follows that the distance from the origin to root 2 is d equals root 2 minus 0 squared plus root 2 minus 0 squared. And in this case, we see that we have square root of 2 all being squared, so that's just 2. So really we have 2 plus 2, which also is going to be 4, which is going to equal 2. And so thus, now we've said that the radius had to have been 2. the distance from our origin or our center to the point in question is also 2. Thus, we've proven that it actually does on the line. So I would say, therefore, since the distance from the center to root 2 equals the radius of the circle, it holds that the point root 2 lies on the given circle. Close proof.